All right, for what values of x and y must a, b, c, d be a parallelogram? For number 7, we already know that the BD diagonal um, is bisected, so we don't need to worry about that. What we need to determine is what value of x would make AC be bisected, make both of those sections be equal. So what are we going to do? We're going to set 3x equal to 4x minus 5. And you may have remembered or heard my trick, which is to say that this is 3x. If we want this to be equal, but we added an x on, that added some value on, assuming that x is positive. Okay, so if we added something onto it, how do we compensate for that one extra x we have? We subtract 5. So that must mean that x is equal to 5. I'm just saying that as a way of knowing that you can start to mental math these. But let's just solve it out proper so you can see. Minus 4x, minus 4x, and we get negative x is equal to negative 5. And if we divide by negative 1, which is the coefficient of x, then we get x is equal to 5, as we saw we would get, because one more x means it's added some amount. We subtract 5 to compensate for it. So that's number 7. Sorry, trying to draw a line there. Not sure what's going on. Okay. Number 8. Well, we know that we've got now two different values here. We've got x and we've got y. So let's start with x. 2x. Hold on a second. Sorry about that. My pen was glitching out there a little bit. Let me erase this. And then, okay. So we know that based on these two segments, which need to be equal, 2x needs to be equal to 4. So we say 2x equals 4, divide by 2, x equals 2. Now, what do we get for these sections for y? This section and this section have to be equal. That is bisected, so we can say y minus 1 is equal to 2y minus 7. Minus y, negative 1 equals y minus 7, and we add 7 to both sides, and we get y is equal to 6. And let's see how that worked out by just plugging it in. If this was 6 minus 1, we'd get 5. And if this is 2 times 6, or 12, minus 7, we'd also get 5. So that works for us. Okay, last one. What do we got here? Well, we know that in a parallelogram, the diagonals the angles opposite each other are going to be equal. Why did I choose that instead of choosing, let's say, consecutive angles, sum to 180? Because what we're looking for is if we can set a pair that have the same variable, if we can use a pair that have the same variable, then we have just a single equation. And we don't need to do systems of equations. So we can say 3x, what's that angle be, equals 4x minus 21. Again, really quickly, you should be able to see that x needs to be equal to 21 because this side on the right has an extra x. So how do you compensate for that? By taking whatever x added on, back off with that negative 21. So it must be 21. But let's solve it and you'll see. Okay, so minus 4x, and we get negative x is equal to negative 21, or I'm going to just skip some of the math. I know that you know how to do the math, and it's going to save time and particularly space. So x is 21, okay? Now, let's do it again. Let's do a different color here. And we have the diagonals 3y. Sorry, not the diagonals. I shouldn't say the diagonals. I should say the angles opposite each other. 3y and y plus 78. So let's subtract y from both sides. And we get 2y is equal to 78, or y is equal to 39. That's how you do it.